All right, so polar, nonpolar, and amphiphilic molecules. So polar, we already talked about this. Water, for instance, is a polar molecule. Here's O and here's H. And the oxygen is willing to steal the electrons from here. And because it steals them, this end gets negative and that end gets positive. Don't quote me on that, but I think that's basically the way the chemistry goes.
Talking about that, last week.
And alcohol is the same. So I think alcohol is like CH, so a simple alcohol. I think this is methanol, OH this way. Similar thing, where, and it's even more polar than this. And I think it's because, this I might get wrong. I'm pretty sure it's again like this, where this end it's positive again. But the idea is that you have an arrow direction between the charges, like this, and that's the pole. So that's why it's polar. Non-polar, so these are polar right here. So this is alcohol, and you can go look this up. I'm not an expert on this. This is water. Non-polar molecules are things like oils, and oils kind of look like this.
Like a continual W.
And so this has two bonds here, and then it'll have two H's like this on each one. H, and if it's a terminating one, then it'll have three H's on it. So this will have two like this, and this will have like three. And so this is, let's see, this is, it's not quite propane, it's the one before, maybe butane. I can't remember which it is. Anyway, but these are oily. The longer these get, the more they get to be like a liquid, and the really long ones. But the point is that there's no charges being pushed back and forth, so it's neutral all around. And there's lots of other non-polar kinds of solvents. I think this is actually a gas, but if you make the carbon chain a little longer, it'll be an oil. And so the difference between these two is that some molecules prefer a polar solution to a nonpolar solution, so some things will dissolve here where they won't dissolve here, or vice versa. Amphiphilic molecules are interesting because they are in between, right? And that would be something like soap. So,
Okay.
So the chemical.
It dissolves in water, but it also breaks down oil.
Well, I'll show you in a second. So the chemical way we write this, oils, is like this, where every corner has a carbon on it, and we ignore the hydrogens. It's a shortcut. It's a shorthand for this. So these are oily things. Polar things, then if we have an amphiphilic molecule, it would go like this, and you might have a polar group on the end, like this, right?
Okay.
And so this is nonpolar, and this is polar on this end. And what you get is something that naturally forms things like this. So if you have little things like this, so these are polar, and you have wiggly bits like this.
You create a sun.
Wiggly bits like this. And so, and here you might have water, and out here you might have oil.
Is that how water droplets
so
form in water?
so soap would do the exact same thing, but it would do it oppositely. It would do this, like this, but it would put
Push
the oily, and so these things right here are called, like, one of the things you might call them an oily tail. Literally, that's what, so in here this might be an oil, and outside there might be a water out here. So soap would behave like this.
Does this mean that it pushes in towards the water,
Well,
and this
these
means
are
that
kind of
it
like,
pushes out from the oil?
So these are kind of like cells. And I'll show you more in a second on that. But the idea is these, it's amphiphilic. The amphi part means both. So it likes both. It likes oil and water. Each end is a little different.
So soap is just...
So in cooking, we have a word for this, and we call them emulsifiers. You might have heard that word before.
Yeah.
All right. Emulsifiers are amphiphilic. And milk tends to be one of those things. I believe eggs can participate in this. There are several other things in your kitchen that will behave like this. And I have a list here. Again, I'm not I don't keep this stuff in my
Flour?
head. So
Is it usually a liquid or
so
is it?
let's stop this and we'll